Hello everyone, this is our IoT project titled IoT as Weather Station. Me myself Shravan Korthiwada and I'm working with my teammates Vishal Salvankar, Shailendra Sharma, Gaurav Malik, Abhinav Sharma. These are outline introduction, importance of application, problem statement, objectives, related work like national status and international status, design model, block diagrams, algorithms, flowcharts. And we have requirements. In that requirements, we have hardware components and softwares. In introduction, we are going to talk about IoT and what is IoT. Actually, what is IoT? Okay, IoT stands for Internet of Things. It is dynamic global network infrastructure with self-configuring capabilities based on standard and interoperable communication protocols. All the physical and virtual things have identities in an IoT system. Importance of the application. Importance of this weather station. Our application has great importance since we can analyze the weather conditions and be aware of the current calamities. IoT weather reporting system has application to farmers as well. It plays very important role in the field of agriculture. It directly or indirectly influences the economic sector. Need of IoT. Sensors are used which converts the physical parameter to electrical signals. This sensor integration with IoT help in collecting weather data which is further pooled in cloud for analysis. Internet then display Internet then can display the weather prediction based on the calculations of the inputs collected through sensors. This is the importance and need of that. Problem statement of this project: develop an apparatus and method that could display the current weather conditions using various sensors and display it using Internet of Things and sensors.
Hello guys, I'm Gaurav Malik. As my teammate Shravan Korthiwada has already told about problem statement. Now I'm going to tell you all the objectives of our model. To study various sensors and related technologies, to design methodology for weather station, to develop a low-cost sensor-based control for water conservation, to connect all the sensors through an Arduino and collect the readings, to deploy a system for weather station and to display it. So these are the related work national status, and this is our international status. So these all are the application of our project: wash basin, shower, toilets and garden. We can everywhere in this project we can use this. So this is our block diagram. Rain sensor, Ethernet shield are connected to Arduino microcontroller, and all these sensors DHT11, LDR, BMP085, all these will collect the data and they'll send it to Arduino microcontroller. Then it will give the output. This is our what we have made, the model of our project. So this is the list of our hardware components. Firstly, we have used Arduino UNO, temperature and humidity sensor, that is DHT11, barometric pressure, temperature, altitude sensor BMP085, LDR light dependent resistor, raindrop sensor, Ethernet shield, breadboard.
Hello everyone, as my friend told you about the hardware components, we are using Arduino UNO, DHT11, BMP085 and LDR, that is light dependent sensor, and also raindrop sensor. The first one is Arduino. Arduino is an open source computer hardware and software company project and user community that designs and manufactures single board microcontrollers and microcontroller kits for building digital devices and interactive objects. There are various fields of Arduino. It is the heart of our project. The model we are using is Arduino UNO, and its price is almost 480 rupees. The second hardware component is DHT11 sensor. It includes a resistive type humidity measurement component, an NTC temperature measurement component, and high performance 8-bit microcontroller inside it, and it also provides calibrated digital signal output. The model we are using is DHT11 and its price is 160 rupees. The next component is BMP085. It is a rock solid barometric pressure sensor. It features a measuring range of anywhere between 30,000 to 1,10,000 pascals. Pascal is the measuring unit of pressure, which you will probably know. The model we are using is BMP085 and it comes around 200 rupees.
Hello friends, I am Vishal Salvankar, and so we continue our discussion. The next sensor is an LDR sensor. An LDR is a variable resistor controlled by light. The increasing light intensity falling on it decreases the resistance of the LDR. We can calculate the light index using the resistance parameter. The model is LDR and its price is nearly rupees 10, and the specifications are like voltage is 320 volts max, the current is 75 milliampere max, and the power dissipation is 100 milliwatts max. So the next sensor is the rain sensor. It is used for the detection of rain. It can also be used for measuring the intensity of the rain. It has both digital output as well as analog output. This module measures the moisture through analog output pin, and when the threshold of moisture exceeds too much, it provides a digital output. The more water or the lower resistance means lower output voltage, whereas the less water means higher resistance, that is high output voltage on the analog pin. For example, a completely dry board will cause the module to output 5 volts. So the model name is raindrop sensor and its cost is nearly rupees 155. Its specification are like the voltage, operation voltage is 5 volts, area is 5 cm into 4 cm, nickel plate on site. The next component is an Ethernet shield. The Arduino Ethernet shield 2 allows an Arduino board to connect to the internet using the Ethernet library and to read and write an SD card using the SD library. The shield is fully compatible with the former version but relies on the newer W5500 chip. So the model name is HR911105A and its price is nearly rupees 155. Its specification is voltage 5 volts, connection speed is 10 to 100 megabytes. And these are the list of softwares. The first one is the Arduino IDE. As we know, since we are using the Arduino microcontroller, its version is 1.6.9 and it is used to run the Arduino Uno and collect all the readings from the sensors. The next one is the Python. Its version is 2.7 and it is used to send the URL to ThinkSpeak. And the next is the ThinkSpeak, and it acts as a cloud server and displays it in a form of a graph. So we come to a conclusion. To develop an apparatus and method for displaying weather conditions and various parameters of natural conditions in VIT. So these are all the references which we have taken to make our PPT, and thank you.